So, hi, my name is Sabina. I will show you my student card, if you see well. So, I'm going to start to present my presentation. So the title is Titanic Random Forest Model Analysis. So this presentation analyzes a Kaggle Titanic model. The goal is predicting passenger survival and focusing on code simplification, practical application, and effectiveness assessment. The model aims to predict passenger survival based on various features. We will explore the feature engineering strategies, simplify the code for better understanding, and apply it to concrete examples to evaluate its performance. We will assess the model's effectiveness. So, I'm going to describe the problem description. So the problem description is Titanic survival prediction. At first, the objective is predict the passenger survival based on features. These include age, sex, and passenger class and far. Then the data set includes passenger information. Details include demographics and travel attributes. And the target variable is the survived column, indicating whether a passenger survived. After challenge, the challenge lies in effectively pre-processing the data, handling features, values, engineering relevant features, and building a predictive model that generalizes well to unseen data. So the next part explains the feature engineering strategies. At first, intelligent imputation. Missing ages are filed based on passenger titles rather than simple averages, providing more accurate age estimates. Then semantic extraction, raw text files are converted into meaningful categorical features, capturing relevant information from names and other text data. After interaction detection, compound features like age class and age far are created to capture complex relationships between variables. Discretization. So continuous variables are converted into bands to capture nonlinear effects, improving model and performance. So in this image, we can see data pre-processing with data collection restored expansion to 10 transformation data turning cache. We have a lot of steps. 10 traduction, data design. So I'm going to talk about simplification of the code of Titanic Kaggle code. So this presentation aims to simplify and clarify the code used in a Kaggle notebook on the Titanic. The goal is to make the code easier to understand and apply while maintaining its functionality. We will look at a concrete example, apply the simplified code, and justify how it works. So the title of this part code simplification, data cleaning, and transformation. So the clean transform EDF function processes the Titanic data set. It extracts titles from names, inputs, missing, embarked values based on title medians and files missing embarked values. It also creates family size and is allowed features, and numerical columns are scored using mean and standard deviation. So for the next step, I will apply the simplification. For the next step, I will apply the simplified code to this example. So practical application, simplified code example. So let's apply the simplified clean transform df function to a subset of data. This shows how missing ages are input based on titles. It also shows how numerical features are scored. Next, I will justify whether the new code works or not. Next, I will justify the new code. So for the next part, I will justify whether the new code works or not. For the next part, I will show you the justification code effectiveness. Effective imputation. The simplified code effectively inputs missing age based on passenger titles and squares numerical features. So effective computation missing ages are filed with title median age, and feature squatting, numerical features are standardized correctly. About clean dataset provides a transformed dataset ready for analysis. And clean dataset provides a transformed dataset ready for analysis. The code inputs ages based on titles and squares features. The data is preprocessed for model training. So well, we can tell that the simplified code effectively inputs missing age based on passenger titles and squares numerical features. And the output shows that missing ages are filed with the median age for each title, and numerical columns are standardized. This ensures that the data is properly preprocessed for model training. So the code works as expected, providing a clean and transformed dataset suitable for further analysis and model building. The key steps of title extraction, age imputation, and feature squaring are correctly implemented. So I will present analysis of additional visualization. So I will present analysis of additional visualization of missing values. So for highlights missing columns, columns with missing data include age and cabin. The visualization confirms that age has a significant number of missing values justifying no. So the visualization, we can tell that the visualization helps in the understanding the extent of missingness and informs the imputation strategies used. And I highlight the columns with missing data provides a visual representation of the missing data patterns. And it shows also a visualization of missing values in the Titanic data sets. And we can confirm, and for the visualization, we can confirm that age has a significant number of missing values, justifying the use of the title-based imputation. The cabin column has even more missing values, suggesting that it may not be a reliable feature for prediction. And for the last part, I'm going to talk about compliance and with instruction and code issues. So we can therefore say that the instruction followed have been applied, and code issues have been addressed in thorough manner. All instructions have been followed. So for the simplified code, the code has been justified, applied, and its effectiveness justified. To apply to a practical example, and he has been analyzed to provide further insight into the dataset. So code simplification emphasizes readability. So code simplification emphasizes readability and maintainability. The code simplification focuses on readability and maintainability while preserving the core functionality of the original notebook. The practical application demonstrates the code's ability to preprocess data effectively. And finally, I will discuss about the key takeaways and next steps. So first, we have feature engineering. The strategic feature engineering improves model performance. Then code simplification. Simplify the code enhances readability and maintainability. And finally, data visualization. Visualizing missing data informs imputation strategies. Next steps include refining features engineering process, exploring imputation techniques, and evaluating the model's performance on the test data. Additionally, consider experimenting with different machine learning algorithms to improve prediction accuracy. And for the conclusion, the simplification of the code from the Kaggle notebook on the Titanic improves the clarity and maintainability of the code while maintaining its performance. This approach can be applied to other data science projects to facilitate the understanding and collaboration. So I finish my presentation. Thank you to listening. Thank you for listening.